Right. Today we are going to see about antenna parameters topic under antennas and wave propagation. So antenna parameters, why we are going to find the parameters of the antennas. So for design, analysis and comparison, we are going to require certain antenna parameters. These parameters quantitatively describe the antenna performance. So first one is radiation intensity. So radiation intensity is defined as the power radiated from an antenna per unit solid angle. It is a far field parameter determined by the power density at a specific distance. It is calculated as the ratio of radiation intensity in a given direction to the intensity averaged over all directions. An antenna radiation parameter is a mathematical or graphical representation of the distribution of radiated energy in space as a function of the observer's position. Parameters are typically measured in the far field region and presented as function of directional coordinates. The radiation pattern is often characterized by lobes classified as major, minor, side and back lobes. Next parameter is bandwidth. In radiation pattern, it is subdivided into segments called lobes separated by regions of weak radiation called nulls. The major lobe contains the direction of maximum radiation. The major lobe Following the major lobe, the back lobe is a specific minor lobe whose axis is approximately 180 degrees from the main beam. The front to back ratio is the ratio of the power density in the major lobe to that of the back lobe. Minimizing minor lobes, especially side lobes, is critical in many systems to reduce interference from undesired conditions. Next one is directivity. Directivity is a figure of merit that describes how well the antenna focuses energy in a specific direction. An isotropic radiator, which radiates equally in all directions, is used as the standard reference for directivity. The directivity calculation formula is given in this slide. Next parameter is gain. Gain is a measure that takes into account both the directional capabilities and the effective efficiency of the antenna. It is the ratio of intensity in a given direction to the intensity that would be obtained if the accepted power were radiated isotropically. Absolute gain further accounts for losses due to impedance and polarization mismatches. The gain calculation formula is given. So front to back ratio, the major lobe contains the direction of maximum radiation and the minor lobe whose axis is approximately 180 degrees from the main beam. The front to back ratio, that is FBR, is the ratio of the power density in the major lobe to that of the back lobe. Minimizing minor lobes, especially side lobes, is critical in many systems to reduce interference from undesired conditions. Next one is effective length. The vector effective length is a quantity used to determine the voltage induced on the antenna terminals when an electromagnetic wave impinges upon it. It relates the incident electric field to the open circuit voltage produced by the receiving antenna. Effective aperture or effective area describes the power capturing characteristics of an antenna. It is the ratio of the power delivered to match load to the power density of the incident wave. The maximum effective aperture of an antenna is directly proportional to its maximum directivity. Next parameter is radiation resistance. Radiation resistance is a threshold resistance used to represent the power radiated by the antenna. It acts as the mechanism for transferring energy from a guided wave to a free space wave. In an ideal lossless antenna, the total accepted power is entirely transferred to the radiation resistance. In a receiving mode, it represents the transfer of energy from a free space wave to the antenna. High radiation resistance relative to loss resistance is desirable for high antenna efficiency. Next, the mind map. Think of an antenna parameter, likely the performance of a stage spotlight. The radiation pattern is the shape of beam on the stage, while directivity describes how tightly the beam is focused on a single performer. Gain is how much light actually reaches the performer after some energy is lost as heat in the lamping house. Thank you.